Welcome to your Load AI briefing. Today we've got a packed lineup. Anthropic drops a smarter, faster Claude. NVIDIA unveils a world model that can handle multiple agents at once. And we've got fresh research on why RL fine-tuning might be gentler on your model's internal wiring. Our top story: Anthropic has launched Claude Opus 4.8, and this one comes with a twist. You can now dial in how much effort the model puts into a task. That means developers can trade off speed, cost, and quality on the fly. There's also a new fast mode that runs 2.5 times faster and slashes inference costs to a third of previous models, plus dynamic workflows inside Claude code. The big picture: Anthropic is giving users more granular control over performance, which could make Claude more practical for production environments where every millisecond and penny counts. Next up, NVIDIA introduced something called World, a generative world model that can simulate multiple agents at once. It uses a clever encoding trick to keep the computation linear as you add more agents, and it can produce real-time rollouts at 24 frames per second. What's impressive is that it generalizes from 2-player to 4-player scenarios without any extra training. This matters because world models are becoming a backbone for robotics, autonomous driving, and game AI, and scaling them to multiple agents has been a major bottleneck. Also today, a new method called Spectral guidance offers a way to control diffusion models without any retraining. It works by projecting conditioning signals, like labels, masks, or clip embeddings, directly onto the sampling trajectory using the model's own geometry. The result? A 37-point boost in conditional accuracy on CIFAR-10 over the best training-free baseline, while cutting sampling time by 4 times. The takeaway here is that we might not always need to retrain models for new control tasks, and that could save a lot of compute. Meanwhile, new research digs into why reinforcement learning fine-tuning often preserves a model's existing capabilities better than supervised fine-tuning. The paper shows that RL keeps the internal computational circuits intact, while supervised methods tend to disrupt them and cause forgetting. Using a metric called differential circuit vulnerability on a 3 billion parameter model, they found RL has a clear mechanistic advantage. This is a useful insight for anyone deciding how to adapt a pre-trained model without breaking what it already knows. And for those thinking about going local with AI hardware, a new cost analysis suggests it could pay off in about 2.6 years. The study looks at a high-end workstation like the GMK-Tech EVO X2 running a 26 billion parameter model continuously, compared to cloud inference pricing from Deep Infra. Of course, that assumes heavy utilization, but it's a useful benchmark if you're weighing the upfront cost against recurring cloud fees. Finally, OpenAI announced the Rosalind Biodefense program, which gives vetted developers and select U.S. government allies access to a specialized model called GPT Rosalind for building biodefense and pandemic response tools. It's part of a broader push to embed safety and resilience into advanced AI for biology. The key here is that OpenAI is trying to get ahead of potential misuse by providing controlled access to powerful models for high-stakes applications. That's your Load AI briefing for today. We'll be back tomorrow with more news from the frontier. Until then, stay curious.